Good evening. This is the first lesson and I'm really excited. Now in this lesson, I'm going to help you to understand how to solve these two equations or how to solve these two problems. All right, so the first problem is the integration of sine squared x, which is a fairly standard question. All right, and the next question that I will show you how to solve is the integration of sine squared 2x. All right, you can see that they are both identical, almost identical, except for the fact that this is sine squared x and this is sine squared 2x. The x here has become 2x. So I'm going to show you, how to solve this and then how to extend an understanding of how to solve this to this particular question. Okay, now this is a question that's very familiar to us. How, the integration of sine x with respect to x. And the answer is, of course, minus cos x plus the arbitrary constant c. Right now, this is really simple and we snap our fingers and we can do this already. Now, this question is a little bit difficult, a little bit more difficult, and the difficulty stems from the fact that we have a square here, right? This is the source of the difficulty. All right, so if we examine the integrand is the function that is to be integrated, right? The integrand is the function that you are integrating. So if you examine the integrand, you will see that the problem is the square. And the question you must ask yourself is this: how to get rid of the square in sine squared x? How to get rid of this square here? Okay, so how to use an eraser and get rid of it. So to get rid of the square, we use double angle formula. And we have 5 of these things. 1, 2, 3, 4, 5. 5 of these things. All right. Now we're going to eliminate the first two, these two. All right, because they are not, they don't have a sine squared x in there. All right, we're going to eliminate these other two also. And again, they are not useful to us. All right, this contains a mixture of cos squared x and sine squared x. This has no sine squared x in there. And that leaves us with this one here. So this is the double angle formula that we are going to use to simplify our integrand. And if you look at, and I've just reproduced it here, right? Let's rearrange this. And when we rearrange this, this is what we get. We bring 2 sine squared x over here, and we bring minus cos 2x here. All right, and the next thing we do is to divide this whole, divide throughout by 2. And when we divide throughout by 2, we leave the sine squared x. And on the other side, we have half minus half cos 2x. Okay, so we have managed to transform the integrand from this sine squared x into this format here. So this is our transformation. And in doing so, we cannot integrate this directly, but this is easy to integrate. So that's what we have managed to do. Get rid of the square here. All right, make this integrand here, which is difficult to integrate, make it into something that's a lot easier to integrate. So let's go ahead and integrate it. So that's our first step, all right, to replace the integrand, all right, with something that we can integrate. The second one is to split up the integrand, and you can see that each of these two parts is a standard question, very, very simple. All right, so that's what you get. You integrate 1, you get an x. You integrate cos 2x, you get a sine 2x divided by 2. Now tidy this up and add the arbitrary constant. Tidy it up, add your arbitrary constant, and you have your answer there. Right. So we're gonna. So in summary, this was what we started out with, and this is the answer to this question. Now let's try to answer a related question. And this question is almost similar to the previous one, except for the fact that you have a 2x here. Everything else remains the same except for the fact that instead of sine square x, you have sine squared 2x dx. Now again, the question is how to get rid of the square in sine squared 2x. How to get rid of this 2 here. How to take an eraser and erase this off. All right. So let's look at the double angle formula again. We are going to use again, we're going to use a double angle formula, but we are not going to use this. We are going to use variant of this formula. All right, and the variant of this formula is cos 4x equals to 1 minus 2 sine squared 2x. This second formula here is a variant of the first one. Okay, so out with that one, we're going to use this. Now, same thing, let's just have this here and let's start to rearrange it. Bring the minus 2 sine squared 2x over here and bring the cos 4x over the other side. So that's what we get. Divide throughout by 2 and that's what we get. Okay, and so we have managed to transform the integrand from something that's really impossible to integrate into something that is manageable. We can integrate this. So let's go ahead to integrate it. And the first step is always to split up the integrand into the two parts. And you can see that the two parts are easy to integrate. One, when you integrate one, you get x. When you integrate cos 4x, you get sine 4x divided by 4. Again, the last step is to tidy up these things and add the arbitrary constant. And that's what we have done here. All right, we have tidied it up as well as added an arbitrary constant. And so here in summary, in this set of slides, I've shown you how to integrate sine squared x. And this is the double angle formula you use. And I've also showed you how to integrate sine squared 2x. And this is the double angle formula that you use. This formula here is a variant of this one over here. All right, I hope you have learned something. Thank you. I will see you in the next lesson. Bye-bye.